in this talk. Hopefully, you guys will walk away having learned a little bit more about testing. So for this talk, I'll be talking about the different types of tests you can do on the iOS platform. But before we get started, I'll just briefly introduce myself. So I took the more traditional route to software engineering. I went to college at Cal and graduated in 2014. So it's been about 5 years now, full-time in the industry. And I actually graduated early, and I did not know any iOS development previously. I was actually mainly a web developer. So I took that time, I took an internship, and then I joined a boot camp called CodePath. And if you haven't heard, CodePath is a boot camp that teaches you mobile development, similar to a Lambda school, except much shorter. So what would happen is I would go to this internship in the evenings, and I would do my internship during the day, and then I would go to this boot camp in the evenings. It was a pretty fun time. And that's actually when I fell in love with iOS and Swift development. So I figured I really liked doing this. So I came back full-time at Apple, and I was an iOS engineer there for about 2 years and worked on a good amount of apps. And after about 2 years, I realized how much I loved online education. So I left Apple to join Coursera to work on their flagship mobile app. If you've used Coursera and their mobile app, chances are you've run my code. So after about a year now from Coursera, I really loved the people I met there, but I wanted a change, and I wanted to work for a company that was very mobile focused. So I was lucky enough to have a few options, and I decided to go to Facebook and be part of their founding team in developing Facebook Dating. So if you've heard, Facebook launched a dating service not too long ago, and now we're in 20 countries. And it's been a really fun ride. I feel very grateful for my experience. And that's me, and that's kind of what I'm doing now. Yeah, and that's it about me. Let's go ahead and talk about the agenda for today. So my hope for this talk is that you will walk away having an idea of the different types of tests you can do on iOS. So here's the agenda. We'll first talk about why testing is important. And then we'll talk about what makes a good test. And then we'll proceed on to talk about the different types of tests that you can do on iOS. And then we'll take a step back, and then I can talk about my personal experience with regards to testing in the industry. And then we'll wrap it up with some key takeaways that I hope you may have learned in this talk. And then we'll open it up for Q&A. Cool. So now let's talk about why testing is important. Most of the people know here probably what tests are, but if you were to ask a developer why testing is important, you might get some really weird answers or really varied answers. Here are some of the things why I think testing is important. One is alerting. So whenever you write tests, you have the ability to get alerted whenever they break. Finding out breakages in your app before users actually see them is what you want. You do not want, the last thing you want is to find out you have a bug when your users are already using your app. So testing allows us to catch these things before they even hit prod. Another thing is with automation. In your career, you may hear of a term called continuous integration. And it's basically a system that allows you to run automated tests whenever someone pushes to your code base. And this really multiplies the power of tests, because once you write a test, it will be run multiple thousands of times even. And that's kind of the gift that test gives you, is that once you write something, you'll always have the alerting and the test for that feature, which is great. It saves you time, and it also allows you to scale. So for the projects you guys are making right now, since it's probably you and a few other people, it may not have the same scale as a company, but testing really becomes important once you start to scale your app. So for example, if your project makes it big and you start having more developers for your project, having tests is crucial, because if you don't, things will just break, and then the app will suffer in quality, and people will stop using your app. And lastly, it gives you confidence. So if you are in the industry and you are refactoring a very complex part of the code base, if that part of the code base has a robust set of tests, and you run your tests against your changes and all of them pass, then you can be confident that you did not regress anything in your refactor. Cool. So now let's talk about what makes a good test. One of them is obviously a test needs to be fast. The faster the test, the faster the feedback loop you will have, meaning it will provide you with faster feedback to you and other engineers. the last thing you want is for you to wait for a long time to get results of your test. Another thing is that tests should be reliable. The last thing you want is for a test to be flaky, because at that point you'll stop trusting your test and it'll just become more of a nuisance than actually help you. Another thing is that a test should be sufficiently isolated, meaning that it should only test the things that you want to test. If you're testing object A and you have no need for object B and C, then you should only be testing object A and mocking B and C. Here are the different types of tests. I won't talk about all of them. Obviously, there's a lot of types of tests. Here are the most common ones that I've seen. The first one is a unit test. It's the simplest test you can write. It tests a single object in isolation. We also have integration tests, which instead of testing one object, you're going to test multiple objects and make sure that their behavior is correct. We have UI tests, which basically try to simulate a user using your actual application, running a set of UI commands and making sure that certain UI properties in the screen are there. And there's also performance tests. So performance tests basically monitor the latency of a certain task, whether that is your app startup, whether it's a single method. Performance tests measure that. And last thing I've seen are snapshot tests, which basically monitors the visual appearance of a certain UI component and alerts you whenever a visual appearance change. Cool. So for this talk, we're going to test a simple recipe app, which I linked you guys to. This app basically has two screens. It has a screen that lists recipes into sections. There's three sections. There's breakfast, lunch, or dinner, and each section will have a list of recipes. Just for testing purposes, I just arbitrarily put a random recipe in each category, so don't mind that. And when a user taps on one of these rows, we'll show a detail view containing more information about that recipe. It has the name of the recipe, the description about it, and a set of ingredients. So essentially, we have three functionalities in this simple application. We have storing a list of recipes. We are going to show a list of recipes. And we are going to show details about that recipe when a user taps on it. Now, let's go ahead and translate these requirements into objects that we're going to use in our app. First is to store the list of recipes. We're going to need a data store. In the project, it's called recipe data store. And then we're going to have another object called recipe list, which will use recipe data store. And recipe list will have the logic for ordering and organizing your recipes into sections. Now, our recipe list table view controller will take in a recipe list and use it to lay out our table view. And when a user taps on one of those recipes, we're going to present the recipe detail view controller. So those are the main objects that we're going to deal with in this talk. So in regards to testing, what I will show you is I'm going to go ahead and show you how to make a unit test for recipe data store. And then we're going to go ahead and make an integration test for both recipe data store and for recipe list. And lastly, I'll show you how to make a UI test that will encompass all of these objects and load up the app, tap on one of the recipes, and check that the recipe detail view controller is properly shown. Cool. So let's go ahead and talk about unit tests. It's the first test that we'll make. Again, unit test tests a single object and its behavior in isolation. There's a few pros to these types of tests. One, since you're testing a single object, it's easy to make. And since you're testing a single object, it's usually really fast. There are some shortcomings for this types of tests, is that because you're only testing one object, it doesn't simulate real-world scenarios. So when a user uses your app, you're actually dealing with a lot of different objects. Unit tests only test one single object. So for this example, we're going to go ahead and add unit tests for recipe data store. Okay, cool. Now let's go ahead and jump into the project. Feel free to follow me in the project. If not, that's totally fine. I'll walk you guys through here as well. So here we have the sample project. We have the recipe data store class. I am not showing you the implementations for this class because you don't need to know about it. All you need to know is the interface so you know how to test it. So in here we have a variable called count, which basically stores the count of recipes you have in your store. We have 4 functions. We have add recipe, to add a recipe given a key. We have getting a recipe given a certain key. We have a thing to get all the recipes, which we'll use later for recipe list. And we obviously have a function to delete a recipe given a key. So let's go ahead and jump to the test file in here in recipe data store test. So you can easily make this file by just going to File, New, File, and typing in test. And you can see that there's 2 types of tests. There's a unit test case classes, which is what you want to create. And basically, once you make that file, you'll get something very similar to this. You see I have a bunch of things here, but that's just mainly for us to test easier. It's just boilerplate code so that I can go through the examples faster. Cool. So a test case class has 2 functions. It has your setup function, and it has your teardown function. And you have your test cases here prefixed with test. Now, what will happen is when Xcode runs your test, it will run setup first. It will run 1 test case, then it will run teardown. So setup and teardown for this test case will actually get run 4 times because we have 4 test cases. So for this example, we're going to go ahead and set up our store, our recipe data store and setup. And for our teardown, we're just going to nail it out to start fresh. So let's go ahead and do that. So for this test, basically, before we start, we want to initialize our recipe data store. So we're going to go ahead and do that. Pretty simple. It doesn't take in anything. And then for after each test case, we just want to clear out our state. So we're just going to nail out our recipe data store just to make sure that we start fresh. Now we're going to go ahead and add our first unit test for add recipe. And all this is going to do is we're just going to add a recipe. And just to verify that the add is successful, we're just going to check the count, make sure it's 1. Let's go ahead and do that. So store.add recipe. And you can see here I already have a bunch of recipes, so I don't need to type that out. We're going to go ahead and add roast chicken with the key, roast chicken key, which is literally just a string. So now we've added the store, and we want to verify its correctness. And for this, we're going to use a suite of methods called XCT asserts. So if I just start typing XCT assert, you can see that there's a bunch of methods that Xcode has available for me. There's a bunch called asserts, assert nil, assert true, assert false. And for this example, we're just going to use XCT assert. And this assert, what it does is that if it's true, then it simply goes to the next instruction. If not, then your test fails. And so this is how testing on Xcode works. You basically have a lot of asserts in each of your test cases. So for this example, we're going to go ahead and make sure that the source count is 1, because that's what we want to verify. And just like that, we have our first unit test case. We can go ahead and run it by clicking this button on the left. And you can see that the test succeeded. There's a green check mark here. If I were to make this 0, which would be wrong, then we can see it fail. Cool. So test failed. And just like that, that's one unit test case testing the add recipe function. Obviously, you can test this much more thoroughly, but for the purposes of this talk, we're going to keep it simple. So let's go ahead and add another test case, which tests adding and getting a recipe. So let's go ahead and add another recipe, which is actually just going to be the same as last one. Add roast chicken. We're going to assert that the add is successful because we're testing adding here as well. Now, the difference here is that we're going to test getting a recipe. So we're going to get the recipe from the data store using the get method. We're going to do, get recipe with the given key. So we're going to get the recipe, and we're going to have a bunch of assertions. Instead of 1 assertion, we're going to have a few assertions. We're going to assert that the object we got is what we expect. So we're going to check the name, make sure it's correct. And we're also going to do the same thing for the description and then for the ingredients. So we'll do that. So if all these pass, then we know that we've gotten the correct recipe from our data store. So let's go ahead and run that. Cool. So test succeeded. So that's another unit test as well. We have a couple of more test cases here. I'm not going to go through that for this talk, but I've left them. You can see the solution in the sample project. So as an exercise, you can try implementing them yourselves. But basically, that's a simple unit test suite for a single object. Cool. Now let's go dive back into the presentation. So that's a simple case for unit testing a single object. Now we're going to go ahead and jump right in to integration tests. So just like, unlike unit tests, integration tests multiple objects together and make sure that their behavior is correct. There are a few pros to these types of tests. Since you're testing multiple objects, they're more similar to the real world, but not really. Integration tests usually span a few objects. If you're testing up your app, you're testing hundreds, if not thousands of objects communicating with each other. Another pro for this is it can be pretty fast to run. Since you're not testing an entire app, you're only testing a few objects. Running them should be pretty fast. Some cons for these tests is it can be harder to set up if your code's not architected properly. Since you're testing multiple objects, if one of those objects is not easily testable, then you might have a hard time setting it up. And again, just like unit tests, it doesn't capture real-world scenarios. These types of tests are still sufficiently isolated from the rest of the app. So for this example, we're going to go ahead and make an integration test for recipe list. Just like what I said before, recipe list will use the data store to get all of the recipes, and it has all the logic for organizing them into sections, which the table view controller will use. So let's go ahead and jump back to the project, and I can show you how recipe list works. Let's look at the interface. Here's what recipe looks like. It has a property called number of sections, which is basically going to be breakfast, lunch, or dinner, so there should always be 3. To initialize recipe list, you need a set of recipes. And this is where our data store will come into use because we're going to use recipe data store get all recipes to initialize this recipe list. And recipe list will have a function called number of rows, which the table view controller will use, as well as title for header and recipe for index path. So now since we have this object, let's go ahead and make an integration test for it. Cool. Here is the recipe list test. It looks very similar to our data store test. I have a bunch of boilerplate code over here, but what I want you to pay attention to is these 2 properties. Since we're testing data store and recipe list, we have 2 references to this in our test case class. So for our setup and teardown methods, we're going to go ahead and set up our data store and go ahead and set up our recipe list. And for each of our test cases, we're going to go ahead and test the behavior for recipe list. So let's go ahead and do that. So for our setup, we're going to initialize a recipe data store, just like last time. We're going to go ahead and add a few recipes to the data store. We're going to have roast chicken. We're going to add, let's see, add cookies in there. Cool. And then, since this is an integration test, we're also going to initialize recipe list. So we're testing 2 objects in this integration test. And what we're going to do is we're going to initialize recipe list, and it needs a set of recipes for its initializer, and we're going to use the data store to get all of those recipes. So now we have our recipe list. In our teardown methods, we want to start fresh, so we want to nil this out. Now we can go ahead and write our test cases. So again, these tests, once you set up your test case class, it should be relatively easy to test for each of these test cases. We're going to use our handy XUT asserts. And for this one, we're going to test the number of sections in the recipe list. In our input data, we have 3 categories: lunch, breakfast, lunch, and dinner. So we expect the total number of sections to be 3. If I added a new category called brunch, then it should be 4. But for the input that we gave the data store, there should only be 3. So we're going to go ahead and test that by doing recipe list dot number of sections is 3. Let's go and run that, and this should pass. Cool. So now we're able to verify that initialize our data store and a recipe list working together has the correct number of sections. Let's go to the next one. And this one, we are going to test get recipe for index path. So given a certain index path, we should get the right recipe. Now we're going to use XCT assert. Now for this one, we're going to assert it's not nil because we want to make sure we get the right recipe given a right index path. So we're going to do not nil, XCT assert not nil, and we're going to use recipe list recipe for index path, and we're going to supply it an index path. So if you supply it row 0 and section 0, it should give us roast chicken because it's in the first section will always be breakfast, and the only recipe we supplied for that section is roast chicken. So in row 0, section 0, that should be not nil. And I know you can make your test more accurate. You can probably check the properties and make sure it's roast chicken by checking the name, description, and ingredients. But for the purposes of this test and this talk, we'll keep it simple and just verify that it's not nil. We also want to make sure that if we supply it wrong index path, it should give us a nil recipe. So we're going to do XCT assert nil now. And we're going to do recipe list dot recipe for instead of, we're going to supply it in. There should be nothing in the first row in section 0 for this one, because there should only be one recipe for the breakfast category, and that's only roast chicken. So let's go ahead and run that. Cool. Now test succeeded. So again, in the interest of time, we will skip doing the last 2 methods. Feel free to do them yourselves. But the key takeaways for integration tests is it is also very similar to unit tests, but you're testing more than one object. In this case, we're testing the data store and we're testing recipe list. Cool. All right, let's go ahead and jump back into the presentation. Now let's go ahead and talk about UI tests. UI tests are actually my favorite and most hated types of tests. It's my favorite because it simulates an actual a user using your app as if it was a real user. And you can have Xcode run commands that you give it and make sure it verifies certain properties about your app. For example, is this button there? Does this element exist? So it's very useful. And that's one of its pros, is that it simulates user interaction, and it's probably it's as real world scenario, it's as real world as you can get because it's trying to simulate an actual user using your app. There are some shortcomings for these tests, obviously. It can be slow, it can be flaky and unreliable. Why is that? Because it's actually testing an actual app, and your app relies on a lot of things. It relies on the network, it relies on the simulator that Xcode is using, it relies on the test account that you're using. So just because a UI test fails does not mean there's actually something wrong with the actual test. It can be something that is out of your control. Another thing is that just because you have a UI test, you can't be confident that there's no error occurring in your app. Mainly because if you don't handle error handling very well in the perspective of a user, your test can be going through the flow, but it may not be realizing that there's errors happening, for example, in the backend or in some lower layer in your app. So for this example, we're going to go ahead and write a UI test. This test will launch our app. It will tap on a row in our recipe list, and it will verify that all the elements are visible in the detailed view controller. So you can see on a video on the right that's what the simulator is going to do. It's going to pump up our app, it's going to tap on the second row, and then it's going to load up the detail view controller for the correct recipe. Cool. All right, let's go ahead and do that UI testing demo. Let's go ahead here. So I go to a file called my recipe UI test. It's very similar to the test case that we've been dealing with already. It has 2 extra calls. It basically just needs to launch the XCUI application. So all of your UI tests need to have this. But what's actually really cool is that Xcode will actually help you write this test for you. So if you see this red button over here and I click that, it will actually launch the app and it will record the actions that I take in the app, and it will write code for me. So like, for example, if I tap on this row, you can see that Xcode is supplying code for that action in our test case file. So if I tap this one, you can see Xcode is generating that code there. If I tap on this one, and even if I swipe, Xcode is actually recording that for me. So it makes it much faster for me to write the test. So I've done all the things I want in the test. So let's go ahead and back out in Xcode and stop recording. Now, the code that Xcode writes is not perfect. You have to tweak it, but it gets a lot of stuff done for you. So we don't need this, obviously, since we already have that above. But let's look here. This is in the table view controller. It makes sure to correctly tap that row. So we want this part of our code. It also taps the name label and the description label because that's what I did earlier. But what we actually want to do is, instead of tapping it, it doesn't do anything if it taps it. We just want to make sure that it exists. So now what we're going to do is we're going to combine what we learned earlier with XCT assert. And then instead of tapping it, we're just going to make sure it exists. So we're going to do something simple like this. And we're going to make sure that it applies to the description as well. And do it here. And we're going to make sure, basically, these 3 things make sure that the 3 labels in the detail view controller are visible and it exists. And you can also see that Xcode is pretty smart. It actually knows when we swipe right and we swipe left. But for the purposes of this test, we just want to make sure that we are able to navigate to the detail view. So we're just going to check the existence of the UI components. I'm going to go ahead and delete that. Now we're going to go ahead and run our test and see what happens. So now you can see that we just made our first UI test. And we were able to make it pretty fast because Xcode helped us make our code for it. Obviously, this can get much more complex. You can imagine having a test for logging in, making sure you land on your home screen, and logging out and making sure you're back in the login screen. So these tests are very helpful. Cool. So that was our UI testing demo. Now we're just going to switch gears back. We're done with the live coding part of this talk. Now I'm just going to talk about what I've learned in the industry in regards to testing. Cool. So first thing I learned, having automated tests are required to make complex apps and scalable teams. So if you imagine big companies like Google and Facebook, before you actually are able to land a piece of code in the code base, hundreds of automated tests run. And you can see why this is important, right? If you have hundreds of developers pushing into one application, things are going to break. And you want automated tests to help you capture that and fix it as fast as you can so it doesn't block development. Second lesson I learned is that testing is a team effort. You are going to get very different answers from people in different companies in regards to their testing. For example, I talked to my friend, I was like, oh, how is your automated testing? You might get an answer anywhere from, we don't do automated testing, we just manually test before we ship, versus we have hundreds of tests run before we are able to land the code. But just remember, when you go into industry, is that depending on your environment, there may be a very bad or very good testing culture. And lastly, you may have realized this, creating tests takes time and has maintenance costs. So obviously, you are paying the upfront cost of writing this test with more code, and you're also going to be paying up maintenance costs, making sure that these tests are kept up to date once you make changes in your app, because some tests may not be useful anymore after you make some changes in your app. Another thing is, if you don't make good tests and your tests are flaky, you will probably end up hurting yourself rather than helping yourself by making tests. Because again, you're going to stop trusting your tests, and it's going to be more of a nuisance for you. Sometimes writing the test is actually harder than writing the feature itself. So you should definitely prioritize which tests are more important and which tests you should spend time working on. Cool. Now we're going to wrap it up. I have some key takeaways that I want to stress. With this talk, hopefully you've realized that there are many different kinds of tests, and they verify different things. Unit and integration tests verify individual or multiple objects and making sure that their behavior is correct. UI, or sometimes people call them end-to-end tests, they verify user flows, and they simulate an actual user using your app. And there are many more types of tests. There are performance tests, and there are snapshot tests that I briefly mentioned earlier that test different things. Another key takeaway is testing can help you scale your team and your app if done correctly. For this talk, I kept it really simple, but these are the foundational things that help apps grow to be very complex and allow them to scale. And again, testing has a cost. I literally just mentioned this a few minutes ago, is that there's a maintenance cost, there is a development time cost. Sometimes you may trade off writing a feature in order to write tests for a very important flow for your app. And yeah, so just keep in mind that testing definitely has a cost associated with it, and you should definitely prioritize it depending on your situation. Cool. And that's about it. That's my talk. I'm happy to answer any questions you might have.
All right. Well, first of all, big thanks to Mari for showing us all about testing. What questions do you all have for him? Got a current Facebook engineer working on a major application used by millions of people. It's a good opportunity to ask questions, things that you've wanted to know about what it's like to be an iOS developer out in the field.
Could you possibly elaborate a little bit more on what's possible with UI testing? Obviously, what you showed us was very simplistic, and I'm just wondering to what degree, do you want to inspect the text that's there and make sure that that didn't change from underneath you, or what kinds of things do you find is useful for UI testing versus what's not useful in UI testing?
Gotcha. So UI testing, I did a lot of UI testing back in my days at Coursera, and we were actually able to do quite a lot of complex things with that. A lot of the tests for UI tests, the cost that you're gonna have is actually setting up the environment properly for your test user. For example, you wanna make sure that your test users are in a state where you can reset your state after every test run. So there's gonna be some cost setting that up. Another thing is for the actual UI test, where swiping, tapping, and all that stuff, that's relatively straightforward. What the most problems you will run into with testing is the flakiness. Because again, sometimes the simulator might not work for some weird reason. Sometimes a backend service is wrong, so it might crash your UI test. So there's a lot of things, because UI tests are all encompassing. There's a lot of things that can go wrong, and actually there's a lot of cost and maintenance related to that. In certain, for some companies, what they actually do is they run UI tests a lot, and since they're flaky, they calculate the flakiness of that UI test, and if it reaches a certain threshold, it will actually alert you saying this is actually probably broken versus being flaky. So those are some limitations of UI tests.
Can you mention some companies or some examples of projects that benefit more from testing versus some that just don't or or benefit less?
Yeah. So like it's you have to be pragmatic in the way you spend time as a developer. It's kind of my philosophy. If you are developing, for example, a very simple application, if it's, for example, it's a pet project, do you really need to make tests for it? Probably. I mean, probably not. If it's not trivial, then maybe you can add some tests for it. But for example, if you go in the industry and hundreds of thousands, not millions of users are using it, then it's time to start thinking about adding some type of testing to your app. And again, it really depends. If you were to give me a scenario, I can answer that question better, but a lot of things depend on your situation.
So in Facebook, do you guys do a lot of testing?
Yeah, we have hundreds of tests that run before you land a single piece of code.
Is there any sources of unexpected flakiness that you've come across that made you change how you write some of your tests?
Are you talking about UI tests in general, or like what
Yeah,
type?
probably with UI tests. Is there something that you learned in the process of having to work with them more that maybe changed your approach?
Yeah. So there are different ways, for example, in UI tests for the simulator to see if a UI component is visible on screen. It can check the actual text. If the text is this strict, then the element is there. If not, it's not there, then fail. So you can actually tell Xcode like, okay, if there's this string in the screen, then it's good. If not, then fail. That is actually, those types of things make a test very brittle because text can change all the time. So like, for example, I've learned not to rely on strings, rather using accessibility labels, which is the preferred way to do UI tests. So you want to make sure that the things you're relying on for correctness are constant and they don't change. That's the main thing I learned about writing UI tests. And also, one thing is that you can't, when you're playing around with an app, it's easy to assume that the network is always good. In UI tests, things can be much, much slower. So keep that in mind when you're writing your UI test. For example, if you have a timeout within X seconds, don't count on it always being that case. If it's in a very bad network, that type of check will probably be flaky in UI tests.
So if you were to give it a time, what time would you default to when you're writing your tests as a timeout?
So I can only say for some of our testing purposes, we time out after like a minute, 2 minutes. So we are very generous in that sense, just because we know the network and the simulator can be very slow and be very bad.
I have a question. I noticed a lot with text fields. If you have the hardware keyboard attached when you're running on the simulator has a issue releasing the first responder status. Is there a way to get around that other than running your unit tests on an actual device?
No, I'm actually not aware of that. Yeah, I'm not aware of that issue. We have our own in-house UI testing framework, and I don't think we have that issue on our side. So I'm sorry, I can't really answer that.
Yeah, I have a question. Which advice you give for beginners, like iOS developers?
That's a very open-ended question. What would I give? I think I would just, be open to learning. It's great that if you are really into a certain technology and you are very passionate about iOS, but being a good engineer means that you're always learning and you're always open to new things, even if you are not comfortable in that new thing. yeah, so always be learning and be open. Don't be dogmatic. Don't be tribalistic. Yeah, be open to the things so you can learn fast and learn a lot.
Kind of related to that, is there something that you know now that you wish you had known, like when you started at CodePath, you started, at an iOS boot camp? Is there something about iOS dev or whatever that you think would be useful to know from the beginning, but you didn't actually learn it until later?
Ooh, I think I'm a much more pragmatic developer. I'm a much more realistic developer than I am now. When I was beginning as an engineer, I always thought, yeah, we need to optimize this. We need to make this better. But dude, if the thing you're stressing out about is not even like, it's only going to happen for 1 out of 1,000 developers, or if it's some weird flow that no one's going to use, don't stress out about it. My big advice is for you to focus on impact and prioritize brutally. You're always going to have more things to do. You're always going to have more things in your plate as an engineer. The thing you want to do is you want to make sure you prioritize, and you want to make sure that the things you're doing have the highest impact out of everything else.
That's great advice. Does anybody else have any other questions?
Just one more question. From your point of view, is there any interesting technologies or maybe like ways of thinking or going about testing maybe that are coming up or that are you using right now?
Actually, for the things that I mentioned, that is actually the things that I think are very important. There's nothing groundbreaking about testing that I've seen, at least externally, that I think is very interesting. Yeah, other than the things that I've talked about, I don't really have anything that I see as like, oh my God, this is great.
And what about outside of testing, other technologies? I know it's not on topic, but I just want.
If you got, I guess this isn't new, but I'm a really big fan of GraphQL. It's an open source thing that we have. It's great for development. I find it very easy to work with. So if you guys are interested, take a look at GraphQL. Also, if you're interested in adopting GraphQL, you can look at Apollo, which is an open source thing for iOS. It's an open source GraphQL client for iOS. Yeah, than that, I mean, I've been dealing with a lot with React Native lately. If you guys are interested in doing cross-platform development, take a look at that. I can talk on and on about cross-platform technologies versus native, but I'm not going to get into that. If you're interested in cross-platform technologies, look at that. And other than that, no, that's what that's kind of what's top of my mind.
If you had to give like a 1 or 2 sentence description of what GraphQL is, how would you describe it?
Oh, that's hard. It's it's a very different way of server-client interaction, where instead of asking your backend developer what is the response, you can easily know that by looking at the GraphQL schema, and you can request the things that you want for your client instead of telling your server engineer not to send you this thing or send you this thing. That's kind of how, I don't really have a good description.
No, that was good. Cool.
It's a really good client.
Awesome. Anybody else have any last questions for Mari? All right. Well, once again, we want to thank you for,
What is Facebook coming up with next in terms of features? Any interesting ones?
We're coming up with a lot. I can't really tell you them, but we are trying to help the community as much as we can given today's environment. So definitely be on the lookout for that. We definitely want to help you guys out. Definitely help the people using Facebook out. That's all I can say.
Nice. All right. Well, thanks again for Mari for coming and hanging out with us and teaching us a little bit about iOS testing. And thank you all for coming and hanging out with us and learning along with him. Have a great afternoon. And we did record this, so I will post this in both the iOS and Brownbag channels soon once we get it up on YouTube.
Thanks,
Cool.
Mari.
All right. Thank you.
Thank you.
Thank you.
Thank you.